Today we're going to start with standard problem number one, which we talked about in our last series of lectures. Standard problem number one asks the question, what is the number of strings of a given length k that use elements from a given set of size n? The answer, of course, is n to the k. We're going to ask, can we generalize this, which was already a generalization of the simpler problems we started with? Well, what would it mean to generalize this? Well, what if we're looking at strings where each position in the string can come from a different alphabet? Here's some important examples of that. Let's look at California license plates. All of you have seen these driving around. What does a California license plate look like? Well, I'll give you an example here of a California license plate. An example would be something like 1 ABC 1, 2, 3. At least this is what I'll call a standard California license plate. There's our California license plates that look very different from this, that are used for government purposes, and very different ones that one can get as a personalized license plate. But a standard issue California license plate will start with a digit 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. They actually don't use zeros, so the truth is it's 1, 2, 3, 4, 5, 6, 7, 8, or 9. I'm going to say one could put a 0 there if one wanted, and they could use 0, so I'll include that as a possibility. Then you have 3 letters. I just put ABC, but they can be any 3 letters. And then we have 3 numbers, such as 1, 2, 3, or 7, 9, 5, or any 3 digits, 2, 0, 1, could be anything. So we ask the question, how many standard variety California license plates exist? How many can be printed if the state decided to print all of them? Well, that could be a tricky question. Let's look at this as a string where the first, fifth, sixth, and seventh letters of the string have to be digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. There are 10 possibilities there. But the second, third, and fourth positions, and I tend to like to think of a string like this with the dashes here that get filled in as above. The second, third, and fourth positions have to be letters from the standard English alphabet. There are 26 choices for each letter. Well, let's go one position at a time. There are 10 choices for the first position, 26 choices for the second position, 26 choices for the third position, 26 choices for the fourth position, 10 choices, 10 choices, and 10 choices for the fifth, sixth, and seventh positions. We're going to see later that you can get the total number of possible strings of this form just by multiplying these all together. Total number of possible plates of this form would be 10 times 26 times 26 times 26 times 10 times 10 times 10. And the common way we'll write that, of course, will be 10 to the fourth times 26 cubed. And when we're talking about answering questions on a quiz or something like that, this will be the form you'll want to leave your answer. Again, it's perfectly easy to understand. There's no need to multiply that out. There will be times, of course, when it's a good idea to know how big this is to compare with other things, because if you're the one deciding on what the license plates should look like, you should know how does this compare with the actual number of cars out there. So there are some times when you'll want to use a calculator, multiply this all out, or just do it in your head if you're comfortable with that sort of multiplication. And as I look at that, that looks to me like it's 175,760,000. So you get in fact exactly 175,760,000 possible license plates of this form. And one thing I didn't mention is that not all of these are used. I did mention that so far at least they've avoided using the zeros. As soon as they started this system, they started with a 1. What happened was before this system started, they didn't even include this first digit here. And you could think of that as being part of this system with a 0 there if you include those old plates, which they don't issue anymore. I'm actually old enough that I remember when they issued plates of the form, just letter, 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 number, number, number. But then they use any digit from 1 to 9 when that digit does go there. I believe my last car has an 8 at the beginning, and they're basically just about done with using up all of the license plates of this form. So they are going to have to change their scheme sometime relatively soon. And one could probably look this up on the internet, what the plans are, because I'm sure they've made plans for that occurrence, but I'm not sure right now exactly what they're planning to do. And that's amazing. With 175 million plus possibilities of this form, they're almost done with that. Our state has 40 million people, and so this is just over 4 per person. Now, of course, not every person has 4 cars, but people do have multiple cars. They come and they go. They don't have to have them all at the same time. And as I said, not all actually get printed up as they go through their numbering scheme. So the 175 million goes a lot faster than you might think. Now, different states have different schemes. If you're in Minnesota, the license plate scheme just looks like this. It looks like 3 letters, for example, A, B, C, then 3 digits, say 1, 2, 3. And these can be any 3 letters and any 3 digits. And just like with California, they don't necessarily use every possible plate of this form, but they use just about all of them. And one can ask, how many license plates are there of this form? Well, it's just we need a 6-letter string where the first 3 positions have to be from the standard English alphabet, 26 choices each, and positions 4, 5, and 6 can be digits. Here's another example would be BBQ, that would be a nice one, 220. How many ways can you make a string like that? Well, the total number of possibilities is just 26 times 26 times 26 times 10 times 10 times 10, or we would just write very quickly 26 cubed times 10 cubed. And of course that number is almost the same as this number in California, only you only have 10 cubed instead of 10 to the 4th, so it's easy to see that the number possible here is just 17,576,000. There are only 17 million license plates of this form. Of course, Minnesota is a much smaller state, and I don't really know how far along they've gotten in terms of using up plates of this scheme, but they probably also will have to change eventually, or in the near future, several years from now, because they'll use up those 17 million relatively soon. Real quickly, I did check New Jersey license plates look very different. Here's an example of a New Jersey license plate. It looks like a letter, it can be any letter in the standard English alphabet. Then you get 2 digits, like 1, 2. Then they put a dash there. Then you get 3 digits. Then they can be any 3 letters, and they can be any 3 letters you want. So a standard New Jersey license plate consists of a 6-letter string. Everybody gets the dash in the middle. 26 choices for the first position, 10 choices for the second position, and for the third position, 26 for each of the 4th, 5th, and 6th position. What's the total number of such plates? It's just going to be 10 squared times 26 to the 4th power. And if you compute that relatively quickly in your head, you'll find that that's just 45,697,600, if I'm doing that correctly.